All right, students, in this video, we're going to focus on the inverse trig functions. And so we're going to start off with, and we're only going to look at the sine, the cosine, and the tangent for right now. And we're going to start off with the graph of y is equal to sine x. So recall that in order to be able to find the inverse of a function, we need to pass the horizontal line test. Well, if we look at the graph of sine x, let me just do a horizontal line test here. We can see we're not going to pass the horizontal line test. So we need to limit the domain of the sine function. In order to be able to find the inverse. And typically the way we limit the domain is we're going to limit the domain of the sine from negative pi over 2 to pi over 2. So we're only going to be considering these values. Notice that if we do that, if we limit our domain to negative pi over 2 to pi over 2, then our entire range of numbers from negative 1 to 1 will be taken into consideration. So we can get all of the values of sine in this domain of negative pi over 2 to pi over 2. And let me just go over the domain for the sine, the cosine, and the tangent, and then we'll talk about what the inverse is. And so for the cosine, if we look at our graph, we can encompass the range of numbers from negative 1 to 1 if we limit the domain from 0 to pi. And so that would be the positive cosine values are going to be found in quadrant 1 and here. And the negative cosine values can be found in quadrant 2. Now let me go back and define that for the sine too. The negative sine values are going to be found here in quadrant 4, but those are the negative values. So if we draw a quick unit circle here, we're talking about going in the negative direction. And then for the cosine, it's quadrants 1 and 2. So we're talking about the positive cosine values in quadrant 1 and the negative cosine values in quadrant 2. Let me mark that for sine. And then for tangent, we have the graph of the tangent. We're going to limit our domain to one cycle of the tangent graph. And so that's going to be here from negative pi over 2 to pi over 2. So it's going to be the same as the sine, quadrant 4, for our negative tangent values, and quadrant 1 for our positive tangent values. So these are our negative values, these are our positive values. And so let me mark the cosine. The domain for the cosine will be 0 to pi, and the range is negative 1 to 1. And for the tangent, the domain is negative pi over 2 to pi over 2. Notice I'm not including those endpoints because those are vertical asymptotes on the graph of tangent. And the range is negative infinity to infinity. So if we think about the function y is equal to sine x, to find the inverse, we're going to switch our x and y. So we're going to say x is equal to sine of y. And if we have y equals sine x, recall that in this case, the x represents the angle, and the output of that function is the ratio. So when we find our inverse, the y value here represents the ratio, and the x represents the angle. Oh, typically we don't say x is equal to sine y. We write this as f inverse is equal to inverse sine x. But in this case, x is the ratio. And another way that we write this is simply y is equal to arcsine x. And the question that the inverse is answering is, what is the angle that has a sine of this ratio? So in the case of the inverse, the input is the ratio and the output is the angle. So we can use the notation sine inverse. The -1 represents the inverse, not the reciprocal. If you want to represent the reciprocal of the sine, you use the cosecant function. But we also can use this language, y is equal to arcsine x. So these are synonymous expressions. So let's look at an example of what that means. So let's say I wanted to evaluate inverse sine 1/2. So the question I'm asking, or you can write it as this, arcsine 1/2. The question that's being asked here is, what is the angle whose sine is 1/2? And the answer to that is the angle is 30 degrees, or pi/6 in radians. So there's lots of different types of problems that we can solve. We're going to solve equations in this way. For example, if I had the equation sine x is equal to 1/2, then this equation is asking the same question. To find the answer, I can inverse sine both sides. Inverse sine of sine of x is equal to the inverse sine of 1/2. And recall that for a function and its inverse, f inverse of f of x is equal to x. So this is just equal to x is equal to the angle whose sine is 1/2. So x is equal to pi/6. And so this relationship here between a function and its inverse applies to trig, but only when we're within the correct domain and range. So let me write that. They applies only within the limited domain and range for the inverse function. That doesn't mean that you can not evaluate inverse expressions that are not within that domain and range. It just means that that particular property does not apply. So I'm going to stop there and I'll go over more examples of that in my next video.